Okay. Now, today I would just want to give you a simple kind of case study where you could understand like how maybe drone is useful. For example, just as you said, as you just talked about the coastal hazard mapping, right?
Mm-hmm.
So, for example, I'm sending you this link. If you open this,
Yeah, I have opened.
yeah. So, what the person is doing is, if you go and look for this data here, you just download this shapefiles.zip and then you open your QGIS. Mhm. Did you reinstall your QGIS?
Uh, no.
Okay. So once you download, did you download the data mentioned here?
Yeah.
Shapefiles.
No.
So once you go and just extract it to a folder, once you extract it, there is this data that starts by the name Arlington and ends by 183. So Arlington and 183. So it is in the very top. So this one, just select the SHP file from it
Mhm.
and kind of drag it in your QGIS, right?
SHX file, right? 183
SHP,
details.
SHP.
Okay.
Once done, let me know.
Um, which one? Like Arlington 2007 underscore SS underscore points dot.
This
What's
one,
that?
Arlington
Points. Okay.
2007
Uh,
assessment dot SHP. Just drag that to your QGIS. And after dragging, if something like this comes up, just leave it to its default and click OK.
there's an error like dot XML is not a valid or recognized data source.
No, no, you're
It,
doing something. Can
it
you
shows that SHP. Okay, let me share my screen.
wait. Let me just do it again and you see what I have done. So I remove it from here. Now I have a empty QGIS. I
Mm,
just go to that folder where I extracted it. I look for Arlington SHP, just this file. not
Oh, okay.
not shp.xml, just shp.
Okay, okay.
Then I drag it into QGIS.
Okay. Yeah. Now I got this the same thing, but it looks more shady. Uh,
Ready? Are you not able to look like this?
yeah. Okay.
So now when you zoom it, let me try to
When I'm
ex
zooming in, it is thick thin. Like not you have the free space, right? But I don't
yeah.
see there's a free space.
Um, can you show me your screen? Just a moment. I took the maybe this is 2004, right? 2007 SS points. STP 183. It should not look like this. You are getting kind of continuous points, right?
Correct.
That is correct. You should get that only. Why am I not getting it?
Oh,
So in these gaps also you're getting some points, right?
mm. Yeah.
Kind of error is this now? Let me have a look on the another file that is. Ma'am, we are starting with one of the tutorials, that is this one. I'm sharing the link here in the chat. So, just until now, we were only discussing the future possibilities in drone and everything, but We just started the practical of class right now, and this is the tutorial. So in this link, when you go here, you can download the shapefiles.shp. It will download here, and the boundary.
Sir, in this tutorial, what you
Ma'am, it is about, like, for example, we are discussing a case study where using drones, they have taken kind of points at each point. This is a lake, and in the lake, they have used a drone to kind of map the depth of each point inside the lake. So this is the data from that drone, and we are kind of going to process it into a result.
okay.
Just a moment. Okay, Setu, will do one thing is now I'll proceed maybe however it is looking in my thing. Just download
Okay.
this file, that is shapefiles.zip, and accordingly just go to Arlington 2007 STP 183 file.
Okay.
Arlington 2000. So this is this file, not this one. So I was
Mm,
before taking the wrong one. So the SHP from here, Arlington 2007 STP 183. Now just
mm,
select the .shp file and drag it into your QGIS. So this is what, like, you flew a drone over some area, and at every point it has given you a kind of the lat long plus the depth of the lake. So it is 525 feet inside of water here. So this is almost similar. So just see how the data was. So if you remember, if you know the point cloud data, right?
mm.
So this is just similar to the point cloud data that you got from the drone.
So can we do it in ArcGIS also?
Yes, ma'am, it is possible in ArcGIS also. So now, for example, someone tells you, okay, with drone, do a bathymetric mapping of my lake, of my some area which is underwater. So when you flew the drone, you got a data like this. So this is the kind of point cloud data. It is not regular here, but uh, so it depends on your flight planning or something. So this is the data. And now next what happens is now we are doing the GIS part. So we have to kind of make it into a proper format that he is able to, or the client is able to understand, or kind of give him a elevation map. So Now, if we have a boundary to this lake, for example, if we had created a boundary to this lake, so according to the tutorial, we look for this boundary 2004 STP 183. So the SHP file here, I drag it again here. So this is the boundary of the lake. Now I just close this. So in this lake, there is also a land, a small piece of land that is they are calling as an island. So uh, when we are processing the final analysis, we don't want anything on that island. We want it to be a of same elevation, right? So there is this island boundary also here, this SHP. So if I drag it into my QGIS, I can see. Okay. So here is the kind of island, right? Now, are you doing it along, Situ?
Yeah.
Yeah. Okay. So see, we have not taken any points where there is the island because we wanted kind of a normal elevation. So now what happens? There is a process called interpolation. So this is a part of GIS techniques. So what happens is, for example, now I want to create a kind of continuous I want to kind of create a continuous raster for this area, like a digital elevation model or a bathymetric map that should be continuous. Now there is places between the points that has no values. So what happens is we use the concept of interpolation. In interpolation, we do is there are many different kinds of techniques. There are many different kind of algorithms that we can use. So, but in basic, what interpolation means is, for example, uh, depending on the distance, for example, this distance is same as this distance. So if its value was 5 and its value of elevation is 3 meters maybe. So 5 meter, 3 meter. So you'll take an average because the distance is equal and you'll, if you don't have a value here, you'll call it 4. So you already have a value here, you already have a value here. So maybe you make many points here. Based on their distance from points near to them, you can assign them values. So similarly, for this whole area, you are able to get a kind of value. From these values, you derive from these values, you derive a value for the empty region also. So that is called as interpolation. There are many techniques to do it. One is called IDW, that is inverse distance weight. One is there is this method of tin. Then there is another method called as, uh, for example, So these are the main interpolation methods: Thiessen, polygon, IDW, Kriging, spline.
Mm.
So this is more of kind of a GIS techniques and processing methods. You will learn this in the classes when you will be doing it, the processing with the imagery or something, then you will learn all these methods. Now, just for example, here they are using this method called as tin interpolation. So that is basically what they do is in tin, if this is my region of interest, anything, it can be anything, and I want to map it using the tin. So in tin, what we do is we kind of segregate the surface into triangles. We make triangles. Uh, Triangles can be of any shape depending on the use case. So we take the complete surface and we make triangles out of it. So in this can be also this was a concept of surveying. Now it is turned into some digital modeling technique. So for example, when there was no drones, uh, there was nothing digital, there was no GPS back in 1800s. So the British India had to survey all of India because they had to lay down tracks, they had to understand the distance of Assam to Gujarat. So that was not possible. They did not know unless one had traveled, but they wanted it on a map. They wanted all of it on a map so that if you're sitting somewhere with a map, you can estimate the distance. So back then a survey was done. So it was also based on kind of tin survey. So if you look on Google about the Great Trigonometrical Survey, what they did was they kind of they kind of used it triangles. So where it was not possible or they had other references, they did not do it, but they kind of made the whole of India into triangles for their survey. Now, what happened with this was, now when they had this map, when they calibrated and made this map and it was publicly available. Now, if you're sitting in Delhi and you want to make some estimates from of about this place to this place, now using these maps, you can do it. So it was one of the earliest surveys that was done to understand the demography of India. So similarly,
Mm.
this technique back then was more physical, but now it has been turned into a digital way. So what happens is, if you have any kind of surface, you are able to represent it in the form of triangles. It has the x, y, and z value at each point. So you can clearly look at it and you can understand how this surface might be represented in this form. So similarly, we are going to use triangulation here to make triangles out of it and a proper surface out of it. So
Okay.
what we do is, there is this processing toolbar, this one. We click here, we write here interpolation. And interpolation, we are able to find out this tin interpolation. Now you understand the concept, what is tin interpolation, right? So you just
To find out the distance between the gaps.
basically we have these points, we are using these points to kind of create a triangulated surface like this.
Okay. Uh,
based from those points,
okay.
right?
Mm.
So there is some algorithm that runs behind that will kind of create from those points this triangulated surface for our region. For
In which cases we are using this, like through LiDAR itself with the DES the through DEM this is possible, right? But since it is a lake, it is not possible through DEM. We are using this, or why we are using it through QGIS tool without
so what
uh,
no
without the sensor.
let me explain. For example, you have a drone
Mm.
that does not have a RGB sensor.
Okay,
It just has LiDAR with it.
okay.
So with LiDAR, you were able to grab this elevation points, right?
Mm. Mm.
So if you have a drone good enough of a good company that provides you the processing in the software itself.
Mm.
So what we are doing, the drone software will do for you. Well, I'm just telling you if you have to do it by yourself, how you will do it,
Okay.
right? So the
Mm.
end product is what maybe if you have a good drone processing software or the company gives it, then you can do it in the software itself.
Okay. Mm.
And yeah. So for
Okay.
example, this is the product of LiDAR. So like you took your drone equipped with LiDAR and it went over the lake and it took the points of elevation.
Mm.
So now those points you loaded in your QGIS and now you want to create a kind of surface or a proper data out of it. So
Mm.
you will go to there are different methods of interpolation. One is heat map, one is IDW, line density. So one the most extensively, not extensively, but the most accurately, the most accurate one to be used in this case is tin.
Mm. Okay.
Now, when you click on tin, so in this tin, we select the LiDAR data. So that is this one. And the attribute we use for interpolation, that is elevation, right?
Okay.
And then we click plus. So this will add it to the operations. Now, what happens next is, if you remember, there was an island here. So that island, we do not want it to kind of, we just wanted to show it as a single elevated layer of a common height. So what we will do is, we will also select island in here and select elevation and add. Since this is where the normal interpolation will break over the island, we call it as break lines. So that it does not interpolate over the island like it is interpolating over the other area.
Mm-hmm.
Just a moment. So now if you just uh, press run, sorry, before pressing run, we need to save it. Uh, and also we need to kind of express the extent of it. So we had a boundary, right? So we want the interpolation. If you scroll down, we want the interpolation's extent. So you click here and calculate from layer to the boundary. So this is kind of you're defining the region where you want the extent of the interpolation. Then there
Okay.
are methods of interpolation. Linear is the most simplest one. Claude Taufer, even I have not heard of it, what this is. But this is kind of a method to create values for the places where there is no value. So,
Okay, I understand the steps. Sorry to interrupt.
yeah.
So we taken the data through LiDAR. If
Hmm.
that is a good software and a premium software, it will be doing all these things within this software itself.
Yeah,
When
yeah.
we are not having that option available, we are
Mhm.
coming to this tool and we are making this manually. Is that
Yeah,
right?
yeah.
Okay.
So, for example, you are some sensor developer. You don't have the money to develop the software for now. You are in development department of a sensor. So you built a LiDAR sensor for yourself and you're just trying to visualize your data. So maybe in that case, or if in because your software is sometimes providing the subscription to do this analysis for a fee and you
Mm,
don't want to pay that fee, so you kind of do it for yourself,
mm,
right?
okay.
So here you select the extent by selecting calculate from layer and you select this layer. Now in here, change the pixel size to 5. It will automatically change all the values and save it as a elevation TIFF. Save it by the name of elevation tin. So I will call it elevation tin 1. So in here you will find the TIFF at the very top. So just save it by a name that you find suitable. Don't forget to select the file type as TIFF. So once you
Okay.
save it and then run it. So if you see now,
Mm,
I've gotten a kind of a depth visualization of the lake. So the
okay.
lowest the highest it hits is 502 meters feet, and the
Mm,
lowest it hits is 550 feet. Now, uh, sorry, I may got it wrong. That is the lowest height here is 502 feet and highest is 5050 feet. Now,
the the more
huh?
thick black is deeper, right? The more thick black.
Yeah, it is deeper. Yeah.
Depth. Okay.
So now if you remember our original data, if you look at it, this one, if I turn this off, so the data was just until here. What actually the when we create the interpolation, what has it done? It has taken the extremities and created a interpolation based on that. Now we will kind of remove this extra part. So what we do is we write here clip.
Mm,
So we go to clip raster by mask layer. Okay. So we select this
So
and
what
in
we
this
are trying to find out from this analysis, elevation means minimum and maximum.
Ma'am, so this was a kind of lake, and we
Yes,
had all the points where our drone went. So we are kind
yeah,
of making a raster out of it. So it is for better visualization, and also it will, for example, before you had like point, so you had an
yes,
elevation depth here at a point, but
yes.
because your client wants a continuous data, now you have at every point you have a value. It is a continuous data. It is not point data. So our main
Okay,
aim was to give him a continuous data.
okay.
So what we have done is we have derived this this black thing, this thing. We have derived it from this data. Now, if you go to clip raster by mask layer, here you see that the layer that you created was the elevation 10, and you want it to be, you want to clip the areas that is useful to you, and you want to delete the extra area. So here you will select the mask layer as boundary layer. That is the original boundary. And you will save it on your PC. Save the file. Maybe call it clipped. And run. So if you see, we have clipped the area of interest. So the area that is not required now is deleted. Now, there are ways to visualize our data better. In point data, we were not able to visualize it. Now, what we can do is, if you go to layer styling properties, if I select this data and if I go to the symbology of it, the layer styling here, if I click this, now here I can see single band gray. Maybe I'll choose single band pseudo color. So if you see, I have different kind of data here.
Okay. So the what it's like the more red, it's 502. It's a
More
502,
red is
540.
more depth.
Okay,
Sorry,
but
more red is 502. So it is 502 is less elevation. 5050 is, it has taken this basis on the LiDAR, DGPS sounder. Okay. So what is, when our drone we were taking this imagery, the taking the points, we have programmed it as such that it takes the distance. The LiDAR is taking the, it is not the sea level or something, it is the distance from the sensor, right?
okay, okay,
So it is like 550 meters away from the sensor. So it is more depth, uh, because the island it shows blue. There is this confusion about it, but don't worry about it. It will be like when you work with your sensor, you will understand if this is the depth. Or for now, I think 502. This is more deep because if this was blue color, it means it is elevated, right? So
mm,
for now, it is at higher elevation. From there, they have taken a reference as uh, a zero, and from that, maybe they are just working with the ground level only. Then they have taken the reference, and that reference, the this island is elevated. So
mm,
this red thing is depth.
okay,
Yeah.
okay.
So you can do many visualizations here. You can kind of choose. Now, what happens is in GIS, there is this one thing. I will change the labor precision to 0 and click classify. So in GIS, there is this one thing called as contours. So contours is kind of giving a similar height, a line, a reference line that joins the similar height. Now to understand this area better, what we can do is we can create contours in it. So if you look for contours here, so export contours. So maybe if you go to raster here and in extraction, you will find contours here. So you select the latest created layer, latest one, that is clipped one. You select the interval between each line. I maybe want it 5 feet. And then you can save this as a to your computer. May call it a GPKG file. That is another format for like SHP file. It is a combined version of if you have multiple SHP files, or maybe you can just select SHP, whatever you feel. So maybe if I select GPKG file, that is geo package layer. I will call it contours. Save. And now if I run it, so if you see, and if I go to properties of this contours, and in symbology, I select single labels. I take the field as elevation and change the placement to curved and apply. Now, if you see, I have a measure of height at every point. So at 545, 540, 530, 525. So in the center, the lake is getting more deeper, right? So they have taken the values as a from the reference of the ground, like from sea level. They have taken the
Mm.
sea level reference, not the sensor level. So in this case, I'm able to kind of visualize the area. So this attaches the, so I know this area beneath the lake is at same elevation. So you're kind of able to create a raster plus vector analysis of your point cloud data, right? So this is the final product. You can export it. You have a TIFF file. You have the contours. You, if you want, you can maybe make your contours a little bit denser. Maybe I can. I want it at an interval of 2,
That
right?
is what the actual line it is, and the one or two in between. Can you show me that line? Which line you are referring?
This one.
The lines in the lake.
Just a moment. Yeah. So this is like you when you see from the, for example, this was the island. So the
Mm.
island was at an elevation at 550. So here the
Okay.
elevation is kind of decreasing and you're going
Mm.
inside the lake. The depth is increasing, right?
Mm.
So this is contours. This is representing same height. So anything at along this line is at 526 feet. Anything along this
Okay.
line is at 528 feet.
Oh, okay.
So
So
this is,
every 2 feet it is giving the line. Okay.
pardon?
Every 2 feet it is giving the new line.
Yeah, I made it like I selected the contour to be generated at 2 feet. You can select
Okay.
zero point 0.5 feet, you can select 1 feet, you can select anything you want.
Okay. Mm-hmm. Got it.
So until now, any doubt like this exercise is done?
No.
Okay, then as I told you, probably with me it was the last session, probably. I will confirm to you it in messages and I will convey Nagendra that my part of the curriculum is ended and he will inform you about how to proceed next.
No.
Or in case we decide upon doing some exercises or maybe some part that is in another, um for example, there is, uh, for example, there is this part that can be done actually without having the like the uh, principles and can be and this can be done with some sample drone data. So I'll be conveying you if some of this we can do. So what we did was just like the exercise we did was kind of exporting and visualizing the output in GIS software, right?
Mm-hmm.
So similarly, there are many other things also here that I can look upon and they do not require you need to kind of actually have a field version of drone before, but you can understand it. So maybe I'll discuss and if I if I will have to have take sessions, I will let you know. Otherwise, if we go accordingly from the start of the curriculum, then my part ends and I will discuss with Nagendra and let you know. Okay.
Oh, fine.
So until
So
now, from the very start of the things, if you still have any doubt or maybe if you want to repeat anything, you can just let me know.
okay,
Yeah.
got it. Okay.
Okay, then I will get back to you.
Okay,
And
So
sir, will you join class after this class? Actually,
pardon, ma'am?
sorry. Sir, after this class, will you join for installing software?
Yes, ma'am. We can do one thing is, Setu, you might leave the class and maybe I'll continue with
sure.
ma'am to have the software install.
Yeah, sure.
Okay.
Thank you.
Yeah.
Thank you. Bye.
Ma'am, did you
Yes, sir.
install
Yes, yes.
AnyDesk? Ma'am, did you install AnyDesk?
Any text?
Yeah.
Yes, sir. Just let me check.
If you go to this website, if you just write on Google AnyDesk,
So
you
let me
just
check. Actually, it was installed, but right now it's any text is not. So I share screen.
yes, ma'am, please share the screen.
Okay. Are you showing?
Yes, ma'am, I'm able to see.
Okay. Yes. First, hello.
Ma'am, just write WebOdium in the space. WebOdium. Yes, here. ODM. Yes, ma'am. Enter. Also, ma'am, just go to one another tab and can you open AnyDesk if you can download AnyDesk? No, no, in the browser itself. If you can just Google AnyDesk. Yes, AnyDesk. This first one. Yes, ma'am. No, 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 no. Just ma'am, on the very end of the page on the downside. Just go down this one, ma'am. I just want the free user online boarding. No, this is the guide. Mhm. Yes, this one. Yeah, keep. Just open it. Ma'am, here in the top there is this computer plus. In above it, on the left, on the left. Ma'am, just go above in the top, very top. Yes, this new session. Just click new session.
Okay.
Yes, ma'am. Just hold on for a moment. I'll copy your numbers. 1 double 6. Ma'am, you will get a request. Accept it. I have taken the remote control of your. Just a moment. How to mute it. Ma'am, if you could choose accept again. If you could accept it again. तू निकलवाया?
What's the use of this software for drone data processing? Hello.
Yes, ma'am.
So what the use of this software for data drone data processing?
Ma'am, it is kind of, it will install Linux in behind and then WebODM will work. But the thing is, it is not supporting. Ma'am, if you can accept again. Because of some system properties, I'm unable to install it in your computer. I don't know why is it not showing WSL. It should have shown WSL, but it is not showing WSL. Because
Oh,
when we install Docker, Docker should work, and when I'm opening Docker for you, it is not working. So, what is the configuration of your computer?
sir, check it. What is? Let me check.
Ma'am, you can do is one thing. Just go to your and at desktop there might be my computer. If you have my computer in your desktop,
Okay.
you can close this.
Hmm.
If you just go to if you go to File Explorer, just open just open File Explorer.
Yes.
Uh, just, just, just press Windows plus E. Windows plus E. Maybe let me share my screen and just go to like your computer here on this PC. If you right click and properties on this PC, if you right click and properties, it will show you all the Ma'am, just press Windows plus E. Windows plus E. Or open any folder. Just there is this folder. Uh, Open any folder in your computer, C drive, D drive, anything in your computer. Just open it. Yeah. Here on the left, there is this PC. Just right click on the left. There is this PC. Right click on it. And there is properties above it. 8 GB storage. It should work. I have no idea why it is not working. If it is 8 GB, it should work. Maybe I'll look through internet, and if I find something that why it is not working, I will we can maybe try install it again. I will let you know.
Okay, okay. So configuration is sufficient.
Yes, ma'am. Configuration is sufficient. Okay, ma'am. See
So,
you.
sir, when I can come
Ma'am, we can try this on Monday.
on Monday? Okay.
Okay.
Okay, thank you, sir.